In this video, I'm going to talk about polarity. In previous videos, I've mentioned the word polar referring to polar covalent bonds. So, as you may recall, I made you a table stating the three different types of bonds depending on the electronegativity. So, the bond. So if the electronegativity was above 2, that's horrible. Above 2, it would be an ionic bond. If it was, let me fix this. If it was between 0.01 and 2, so above 0 and below 2, and sorry, it's 1.9. Well, actually no, it's 2 because this one has to be above 2. So that would be a polar covalent bond. Polar covalent. And well, if it was 0, that would just be non-polar covalent. Non-polar covalent. Well, you get the idea. So when you're talking about polarity, if a bond is polar, I'll just call it bond polarity. That does not mean that the whole molecule is polar. So this I don't know, I'm sorry about that. Molecular polarity. So that does, if a molecule has polar bonds, it does not mean that the molecule is polar. What I mean is that there are non-polar molecules that have polar covalent bonds. So do not assume that if a molecule has polar covalent bonds, the whole molecule will be polar. So in this video I'm just going to talk about molecular polarity. But before that, I have to introduce what are called dipole arrows. And dipole arrows are linked to electronegativity. So they will go from the least electronegative side, or the least electronegative element, to the most electronegative one. So let's say you have two atoms here, and this atom is delta positive, this one is delta negative. That just means that this is electron rich, this is electron deficient. That's with one F, sorry. Deficient. So one atom is electron rich, one atom is electron deficient, and the arrow will point from the electron deficient towards the electron rich. So it will be like this. So a good way to remember is just this side looks like a positive, so it will be in the delta positive side, the electron deficient one, and it just points to the electron rich side. Now back to molecular polarity. A molecule is considered polar if, wait, I'm gonna write it all. Molecule is polar if the arrows, all those dipole arrows, point toward the same end. If so, arrows point to the same end. And as always, I'll give you examples for you to see it. So just the contrary of that, a molecule is non-polar if the arrows point away from each other. So if you have an arrow going like that and an arrow going like that, the molecule will be nonpolar. But if you have an arrow going like that, and then another arrow going like that, the molecule will be polar. So let's solve some problems. So let's say we have this. We have an oxygen here, carbon, carbon, and just hydrogens here. We have this one here. The first thing you want to do when you want to determine the polarity of a molecule is to find the most electronegative element. So in this case, oxygen is the most electronegative element. So we have oxygen here, and what that means is that the arrows will point toward oxygen. So we have two sides here. We have this side and this side. 1 and 2. So we'll have two arrows. We will omit the hydrogens because they don't really make much of a difference. So an arrow will come like this because carbon is electron deficient when it's compared to oxygen, and an arrow will come this way. Now, although they're not like in the same, they're not like the same. They don't have the same direction, you could say. They're still pointing toward the same end. So the only way they would be nonpolar if one was pointing, let's say, like this, and the other one was pointing like this, or like this. If they're pointing toward the same end, the molecule will be polar. So this molecule is polar because, and you can just represent it with an arrow, with a big arrow going like this. So they're both pointing toward that. So you say that when you combine both, the electron flow is going up toward the oxygen. So this molecule is polar. Let's do another one. We have a carbon in the middle, have a double bond here, a double bond here, and an oxygen on each side. So again, the first thing you want to do, determine which of the elements is the most electronegative. Again, oxygen is more electronegative than carbon. So we'll have, so you can just mark it. I'm going to put two dots there. So there will be an arrow pointing this way, and then an arrow pointing this way. And these two arrows are pointing toward different directions. They cancel out. So you can say that this molecule is nonpolar. I'm going to do two more. Let's go with boron. And it's usually bonded to fluorine. Yeah. Fluorine here. Remember, boron usually has 3 bonds, and it has a full octet with that, so it doesn't have any electron pairs, and any free electron pairs. So we have that. Fluorine is the most electronegative element in the periodic table, so we'll mark them. We have 3 fluorines. Boron is electron deficient when compared to fluorine. So each arrow will point toward the fluorine. Goes over there. There. So we have 3 different arrows in this case. And well, they're all pointing in different directions. So this molecule is nonpolar. Nonpolar. I'll do one more. In this case we have carbon in the middle, hydrogen here, chlorine pointing out, in, and like chlorine, okay. And by determining which is the most electronegative atom, chlorine is the most electronegative. And hydrogens don't tend to matter when you're doing polarity, so we'll just omit them. So one of the arrows will point from the carbon to the chlorine, like that. Another one will go like this. Now this is a tricky example because you may think that the arrows are pointing in different directions, but the molecule is actually polar. Because the only way this molecule would be nonpolar is if instead of this, that it has to be like that. You just think of it as they have to cancel out. So what happens in this case is, I should have drawn this a little bit more. Like that. Is that you can actually have a net dipole, like an arrow come like this when you combine both of them. So they're kind of pointing toward the same end if you divide it into quadrants. So this example is a little tricky to do, but if you don't see them actually canceling out, it like on the opposite direction, like one like this and one like this, and one like this and one like this, the molecule will most likely be polar. So they have to be like the absolute opposite of each other. And actually, I'll give you one more example because I didn't like how the example went. It was not the best example. So let's say we have this phosphorus, we have one fluorine here, one fluorine here, one fluorine here, one here, and one here. Phosphorus has usually has 5 bonds to have a full octet. So, and fluorine is the most electronegative atom, so all the arrows will point toward the fluorines. So it'll be like this: 1, 2, 3, 4, and 5. Now you have a lot of arrows right now. You can see that these two are canceling each other out, and this 3, you can just say this two or a big arrow like that. These two are canceling each other out. So as you can see, they're in absolute opposite directions. One is going down, one is going up. Out of this two, you just say it's going to the left, and out of this one, you could just say it's going to the right. So they're all canceling each other out. And then the molecule is considered nonpolar. Well, that's molecular polarity. As always, if you found the video helpful, like it and share it with your friends.